Alright, ladies and gentlemen, welcome back yet again. Alright, now we're talking about dividing polynomials here. This is 2.3 day 1. We're going to be dividing polynomials using both long division and synthetic division and evaluating polynomials. We'll get to exactly how we'll do that later. This is a huge Algebra 2 review other than the 5th grade review that we're about to do right here, but here we go. Alright, if we have to divide just two regular numbers, we're about to do this with polynomials, so if you're wondering what the heck I'm doing, okay, we're just going to play compare and contrast in just a second. Okay, but 297 divided by, so there's 296 divided by 7. Well, of course, what that means, we need to put the 7 outside the little division bar thingy, whatever you want to call it. I don't really care. Alright, and then you put that, and then you ask, okay, does 7 go into 2? And if it does, great, you put a number up there. If 7 goes into 29, oh yeah, it does. And of course, it goes into 4 times. And then after you put that number up top, you multiply. 7 times 4 gives us a 28. Second I write that number down there, I'm thinking, oh, I need to subtract. So we subtract 29 minus 28, works out to be a 1. And after you've done that subtraction, you just take your next digit, bring it down, and you get a 16 in this case. And then, you know, it's shampoo, lather, rinse, repeat. So now I'm looking at the 7. Okay, does that go into 16? Well, it sure does. It goes in twice. And then again, we multiply, getting a 14. Again, second we do that, we think, hey, let's subtract, and then we get a 2. Okay, now since I'm looking for a mixed number here, I need to do something kind of special. Of course, if I want a decimal, I put in a decimal point, throw some zeros out there, and keep going. But as a mixed number, basically this becomes your numerator to the denominator of 7, and so it might be a little awkward to write it in here, but this is 42 and 2/7. Okay, and just because I'm going to contrast, well, talk about what's going to happen in just a second. When I write 42 and 2/7, this is the one time in math where you write something next to something else and it does not mean multiplication. Alright, well, if I have 42 and 2/7, notice the word and gets slipped in there, and implies an addition. So 42 and 2/7 actually means 42 plus 2/7. Okay, just keep this in mind as we go, because as soon as we start doing variables, it's going to be a lot nicer to think of it this way as opposed to trying to write things next to each other, because the second you see variables next to each other, you know it's multiplication. But because of the way we handle mixed numbers, it's not all the time. So there that is. That's the 5th grade lesson for today. Let's move on to some high school stuff. Alright, now let's move into high school. In high school now, we can divide polynomials. And we can do this a couple different ways. First way is just regular long division, which does have its uses. So for those of you remembering the synthetic division and going, why bother? Well, sometimes it's important. But anyway, here we go. Okay, of course the thing you're dividing by goes out in front, just like the 7 from the last example had to go out in front. And then the thing that you're dividing into, in this case this big old polynomial right here, that goes inside, underneath, whatever you want to call it. And then we're ready. Okay, now basically each term of the polynomial is kind of like having the digit of a number. So this is a 4-digit number inside here, this is a 2-digit number outside, and we're just going to divide. Although you don't exactly handle them like digits, basically what you want to do here with the polynomials is try to match first term to first term. So basically kind of like first digit to first digit. I want to figure out what I can put up here to multiply by x to make 2x to the 3rd. And hopefully it doesn't take too much thought to come up with 2x squared right there. Okay, and just to make sure everybody's on the same page here, the 2x gets multiplied by the x minus 3. You want to multiply by the entire thing out in front. So it's basically a distribution. And so what that gives us is a 2x to the 3rd minus 6x squared. Okay, now I don't need you to write that out there, but if it helps you, great. Okay, now moving on from here, we are now going to subtract. Okay, so I would advise this at least. Okay, since subtracting is the same thing as adding the opposite, what I like to think of this is instead of subtracting what I have here, I like to think of it as adding the opposite. So basically what I do is I change the sign to a negative 2x, and then where people mess up is they don't change this one. So make sure you change all the signs. And so now I'm adding, because you, me, everybody, we make far fewer mistakes with addition than we do with subtraction. Alright, I hope I said that right. Anyway, here we go. And now we add these together, giving us a negative 2x squared. Okay. After that subtraction takes place, you just bring down your next digit, and then again, just like I said in the last one, it's shampoo, lather, rinse, repeat. You just kind of keep cycling through the process. Match the x to the negative 2x squared. So in this case, it's going to take a negative 2x. So we're going to distribute a negative 2x into the x minus 3. Okay, giving us a negative 2x squared. Again, these should match. If they don't, check your work. And now this gives me a positive 6x. Okay, whoop. And again, now just my own personal thing. Ignore that stray mark. I'll just get rid of it. Alright, we can now again change the signs and add instead of trying to subtract and worry about all those sign mistakes that could happen. So changing those signs gives me nothing here, and this gives me a negative 2x. Okay, I promise they won't always work out to be 2's. Alright, bringing down the next term gives me a negative 13, and notice it's the last digit of my number. So this is the last kind of repeat that I'm going to do for the basic cycle of this thing. After I'm done here, I'll have a remainder. Alright, so anyway, what times x is going to be a negative 2x? Well, that's going to be a negative 2. So now I'm distributing a negative 2 into x minus 3. So I get a negative 2x plus 6. And again, taking out my magic red sign changing pen, I get a positive 2x and a negative 6. So that gives me a negative 19 as my remainder. Okay, now the book and I will do this a little bit differently. What I like to do is just always slap down a plus sign, because mixed numbers are always something and, so something plus. So I like to put down a plus sign and then just put that remainder, whatever it is, and again I always put this remainder on top of the thing out in front. So this is going to be an x minus 3. Alright, so for me this is the answer I would give. Okay, the book on occasion, at least, what they'll do, and basically they take that negative sign down. So what the book will do on occasion is give us a 2x squared minus 2x minus 2, but then they'll kind of bring that negative sign down in front and do this as a subtraction instead. So then it's minus 19 over x minus 3. Now technically those are both correct and mean the same thing. I just think this fits with the whole mixed number idea better than what this does. Admittedly, maybe the book's is a little bit more simplified than mine, but I think mine's a little more true to the actual feeling of what's going on with this problem. So basically I'll leave it up to you. Either one of those I will accept on a quiz. You make the call. Now of course some goofy things could happen, so here's one of them. Alright, if you're dividing this guy by x squared plus 2, okay, now again for those of you thinking synthetic division only works in situations unlike this one, and we'll get to that specifically in an example or two. But as soon as you have an x squared or something like that, you can't use synthetic division. It just falls apart the way the process works. So this is a case right here where you have to use long division. Also, another thing that's really, really helpful is as you're starting to set this thing up, any missing powers of x, both in either half of this thing, basically what you want to do is add in kind of placeholders, if you will. So 0, whatever power of x you're missing, including if you're missing a constant. So if this was just an x squared, I might write x squared plus 0x plus 0 to help keep things lined up. Alright, but we do have the 2 in this case, so I write x squared plus 0x plus 2, and then again throw up my big old division bar thingy. And then again, I'll write what I've got, x to the 5th plus 3x to the 4th. Oh, wait a minute. I don't have, oops, that should be a 0. I have 0x to the 3rd, but I also don't have an x squared, so actually just to keep things lined up, I'd throw an x squared in there too, until I catch up to the actual powers of x sequentially. So now minus 2x and plus 18. Okay, now I'm not going to bore you with doing what I just did in that last long division, but if you feel so inclined, of course, the answer is down here at the bottom of the slide. That's the answer you should get by doing that division right there. I just wanted to make sure you kind of saw what to do to set it up in case there's any powers of x missing. Alright, now the moment you've been waiting for, at least those of you who remember synthetic division well, hopefully that's most of you, if not all of you. Alright, synthetic division only works when divided by x minus k. Alright, so it's always going to be x minus k, where k is a number, of course. It could be a nice number, it could be a messy number, but whatever the case is, basically what we don't want to have is a coefficient or an exponent. So x with no coefficient or exponent. As long as we've got that, and let's actually write exponent, because some people write that wrong and think something else. So no coefficient, no exponent. As long as you got that, then you're okay. And again, you guys have seen this before, so pardon me, I'm going to go through a little bit quickly, but here we go. Alright, whatever you're dividing by, in this case x minus 3, instead of the x minus k, so basically k is 3. Alright, and people use slightly different notation for this and slightly different lines and things of that nature, so if you have a slightly different version of this, I'm okay with it. But my version of this, I like to put 3, that's my k value, and I basically put it in a little like backwards L, I call it like a box. Alright, and from there, we're just going to list our coefficients out. So I've got 2, I've got -8, don't lose those signs, I've got 4, and I've got -13. And then what I do is I leave a line for writing other numbers, and then I kind of underline the whole thing. So basically, if this is notebook paper, here'd be one line, then it'd be a blank line, and then this line down here will be like my answers. And then actually what I do, and again, not all people or books do this, but I put a little bar here separating, because this is kind of like my remainder box. So I basically want to separate my fraction-y stuff from the rest of it. Okay, and then basically you just let gravity start working at first. So whatever this first number is, you just bring him straight down. You don't have to draw that arrow, I'm just doing that for effect. So you draw that straight down, whatever it is. I don't care what the number is, drop it straight down. And then you're going to multiply. 3 times 2 gives me a 6. Okay, and then we just add. Okay, -8 plus 6, well, that gives me a -2. And then shampoo, lather, rinse, repeat. Whatever number's down there, you multiply it by the front guy, and then you write the answer in the next column over. So 3 times -2 is -6. Adding those together gives a -2, and hopefully those numbers are looking familiar. 3 times -2 is -6, and then gives me a -19. Okay, hopefully you're catching on now. Hey, this was the original example that I did first. Yes, you're right. Okay, so basically, if this is the original example, even by a different technique, I should still get the same answer. Alright, so like I said, that 19 is my remainder. So I've got -19, and that always goes over what you divided by. Now granted, I kind of used a 3 here, but remember what that represented was x minus 3. So that x minus 3 is my denominator, and again, I like to throw a plus sign in there to separate it from the rest of the normal polynomial looking part of my answer. Okay, and then from there, you know, all these 2's represent various powers of x. A couple different ways of thinking it, and from my bar, this is the constant, so this is x to the 0 power basically, and then this would be my x to the first, and then this is my x to the second, and you just keep counting it from there. Otherwise, you could think of it, make that a little nicer too. Otherwise, you can think, well, I'm having an x to the third, and I'm dividing off 1 power of x. Well, if I do that, well, I sure should get x to the second here. Basically, I'm dropping 1 power of x off, so second, first, 0 counts down, and just a way of double checking yourself that, you know, things should line up and the power should work out, that you end up with no x's right before you get to your remainder. Doing something like that would work out pretty well. But anyway, moral of the story, this should be 2x squared minus 2x, and then minus 2 plus that -19 over x minus 3 is that other problem done using synthetic division. And I'll admit, most people prefer synthetic division whenever it's able to be used, myself included, but there's how that process works. Alright, now one more example again, just because some odd things can happen, and here we go. Okay, so now I'm dividing by x plus 6, this big long polynomial there, and okay, some people might be going, hey, you have to be dividing by x minus something. Well, really you are. In this case, you're really dividing by x minus -6. Okay, obviously we don't normally write things of that nature, but that's really what that means. So again, as far as my box, if you will, I put the -6 in the box, and then again I write my coefficients down. So my 3x to the fourth, and then 16x to the third, and then wait a sec, I don't have an x squared. So I sure better add in something to hold its place. Alright, and then I get my 67, and then I got my -30. Alright, underline, etc., remainder box. Okay, now again, that 0 is hugely important in synthetic division, because you're not throwing x's out here anywhere, so that you won't ever notice that you don't have any like terms or something like that. Like if we were doing this in regular long division, you know, you have all the x's and all the exponents attached to them, so if you make a mistake like this, you might notice as you're doing your work that, hey, wait a minute, these aren't like terms, something went wrong someplace. But with synthetic division, with just the bare numbers, you would never notice that. So it's really important that you get things in the right spot at the right time. Alright, so with that 0 in place, again, just kind of do the whole thing, and normally, you know, I might just skip the answer here, but what the heck, this synthetic division stuff doesn't take hardly any time at all, so why not just buzz through it really, really quickly, and hey, look at that 0. Alright, so we got 3, and again, this is a 0 power, first power, second power, third power, or alternatively again, started with fourth, divided off 1, so having a third power answer makes a whole lot of sense to me. So then -2x squared plus 12x minus 5, and of course saying plus 0 over something is kind of silly because 0 divided anything would be 0, so you'd be adding a 0 on the end of it, which, so basically, don't freak out if you don't get a remainder. Sometimes things divide evenly. And so there you go. Big thing about that one is make sure you get that 0 in there from any missing powers of x. Alright, just a quick word about this example here. Hopefully when you look at that first polynomial there that we're going to divide into, your skin just kind of crawls on you a little bit. Because that's ascending order. Oh, how horrible. Okay, synthetic division is built off of having descending order. So either one of two things. Either just rewrite that thing so it's in the proper order, or quite honestly, as you're transferring numbers down to the synthetic division, just make sure you put them in the right order as you do it. Okay, so anyway, there you go. Because the problem with synthetic division is if you kind of blow the setup, then anything you do from that point on is complete gibberish. So 1, 3, negative 8, 12. Boom, boom. Okay, again, if I wrote 12, negative 8, 3, and then 1, the synthetic division process wouldn't have any idea of things being out of whack. So just make sure you do that. Whoops, my underline died. But there you go. So that'd be the answer you got if you actually follow through with that. I'll save you the time right now. Alright, now we can also use synthetic division for evaluating polynomials, which I personally think is one of the coolest things about it, because obviously that you can divide with synthetic division, there's a big shock, but its ability to evaluate polynomials is actually a really, really cool thing. And here it is. Alright, so of course if I've got this polynomial and I want f of 4, okay, again, without any sort of idea of how to do anything otherwise, okay, just say, of course, f of 4 equals 4 to the third minus 7, 4 squared, etc. Alright, and then you start working things out. Okay, obviously if you have a calculator, you just type that in and call it a day. But for a moment, let's pretend that we don't have one at our disposal. Okay, first of all, we do 4 to the third, and of course we get 12. Just kidding. Okay, 4 times 4 times 4 is 64. Hopefully nobody wrote down 12. If you did, don't tell anyone. Alright, from there on, okay, again, using our exponents first, we get a 16. Multiplying the 16 times 7, everybody knows that's 112. And then 5 times 4 is 20. And then 6. Okay, and then one thing you can do if you're super slick about this is, hey, look, I got 3 positives, 1 negative, so hey, let's put the 6 with the 64, and that makes 70, and then put another 20 with that makes a 90, and then I'm betting you can probably do 90 and 112 in your head, giving us a negative 22. Okay, so even by hand, it's really not that gruesome to do that. Okay, however, okay, if we're going to divide by x minus 4, that means I'm putting a 4 in the box. Now notice that 4 is like our k value, so then this f of 4, the number used in here, kind of goes to the opposite thing here and kind of reverts back to its original there, which is a little bit weird, but kind of a double switch. But moving right along, if I'm doing that synthetic division, okay, my coefficients are 1, negative 7, 5, and 6. Again, looking at the original polynomial there. Again, throw my remainder box down, and as I do this, I get a 1 multiplied by 4. Okay, adding gets negative 3, multiplying gives me a negative 12, adding gives me a negative 7, multiplying gives me a negative 28, and then, hey, wait a minute, that gives me negative 22. How cool is that? So, if you need to ever evaluate a polynomial by whatever number, instead of doing this, and, you know, because certain numbers of powers, sometimes they're easy, sometimes they're not. I mean, I'm sure everybody knew 16 times 7 was 112, and I'm sure everybody knew that 4 to the third was 64. Even through the computer. Can you smell the sarcasm? Alright, but anyway, if you notice through here, the biggest number I had to deal with the whole time is a 28, as opposed to here where I was dealing with all kinds of nastier ones. So sometimes it's actually easier to do the synthetic division than it is to do the kind of other straightforward method. But anyway, just something you can do. I think it's awesome. Alright, and here's the assignment. Okay, now again, number 3 is kind of on its own, and then out of 5 through 15, do at least 4, do at least 5. If you're only going to do 4 and only going to do 5, you know, make sure you're doing the harder 4 and the harder 5 out of the chunk. Don't just do the easy ones and say, oh, I've got it mastered. Okay, hopefully you know better to do that by now. And hopefully you think this is a lightweight assignment. If that's the case, start looking at the 2.3 video. This is a little more hardcore, a little more involved, a little more conceptually challenging. So if today was pretty simple, maybe get a head start looking ahead, because tomorrow's not going to be quite so simple.